Okay, let's go to number 2. For number 2, what's going to be checked? Okay, what's going to be cached? Sorry, what's going to be cached? So now let me use the color here. So number 2. So what number 2 will do is we're going to cache some account objects. So for number 2, it's going to be old accounts ID. Oh, actually no ID because it's broken over here, right? So it's no ID. Sorry about that. It's only up to I over here. So that one there is actually going to be assigned to exactly this expression here. So it's going to be assigned to accounts I. So remember, this variable here is it's hidden from you as a user, but it exists so that they can be checked at the post states. So now if we do that, so that means this particular variable is going to accounts I is referring to this particular object over here, right? So now that means, visually speaking, old accounts I is now a reference copy of this particular objects. Okay, good. Let me just do, so all these variables exist in the pre-state and also they are visible in the post states. Okay, so now let's do number 3. Number 3 is very interesting. Number 3 over here, we are still trying to catch the value of the accounts, but a shallow copy of that. Okay, so now I would like you to again draw your connection to the previous example where we do the old imp, right? We say imp, old imp is assigned to imp.twin. That's exactly what's happening over here. So now if you try to do this, so this is the expression to cache. So number 3, let's say number 3 here. In number 3, we are actually going to have old accounts I and then twin. So in the naming convention, I'll just disambiguate by saying twin over here. So that one there is going to be assigned to the whole expression over here. So that's going to be accounts I dot twin. So now you know very well how should we do this shallow copy. We want to do a shallow copy of the objects. So of course, first of all, you will have to create this particular object over here always of type accounts. So I'll put a type over here. And then we're going to do a first level copy for all the attributes. The only attribute we have is the ID. The ID 23 is copied over here. So now that's 23. It's primitive type, so we only copy its value. If it happens to be a reference type, we have to copy its reference, right? We said about that's how we said about the shallow copy. So now this particular variable is now pointing to this accounts objects. That's a shallow copy of the account objects. Okay. So now let's move on to number 4. For number 4 here, it's basically a different type of value to be cached. It's basically going to be the array of accounts object that's being cached. But is it going to be a reference copy, shallow copy, or deep copy? Apparently, it's simply just a reference copy, right? So now I'm putting it here. So number 4 over here is going to be old accounts. Okay, that's simply just that, right? Old accounts over here. And then is assigned to just this particular expression. So I would say accounts. Okay, it's a reference copy. So now it's easy. It will simply just point to wherever account is pointing to. So that's a reference copy of that. Right? Of course, for all the expression, I'm omitting the part about what will be the consequence of aliasing. So combined with your knowledge from the previous example, that's something you should really reflect when you study these notes. Okay, that's about number 4. What about number 5? Number 5 over here. So now we have accounts.twin. So we want to get a shallow copy of the array. So now this will take a little bit more space, right? So let's think about how we can draw it. So I'll draw it over here. First of all, let's list it. So now it's going to be this particular expression that we want to cache. So let me put it here. So it will be accounts and then twin. Okay, that's the variable name. That's going to be cached by this particular example. So it's going to be accounts dot twin. Okay. To make a twin object, we have to make a new object of the array first, right? So that's going to be an array of accounts. So let's create a new array. let's put it here. Okay, so we're gonna have a new array over here. We simply create a new array. Okay, and then so when I say dot dot dot, so that means there might be other elements in the array, but of course you will know how to do it. So now specifically, so dot 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 here, dot 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 here, especially for index I, is now going to be a reference copy, right? It's going to be a shallow copy. So more specifically, you can think about the position I for this array is assigned to position I of this particular array. So that means now I is now going to point to wherever that one is pointing to. And then we are trying to assign this to accounts twin, right? So that means accounts twin is now pointing to the beginning of that particular array, right? So my line is going to cross a little bit, but hopefully it's still readable by you. Like that. Yeah, for this one is so special, so now let me just highlight it. Okay. It's basically looking like this. Okay, it's pointing to just the array, so it's a shallow copy of the array. However, beyond the first level, you can see beyond the first level, we are still doing just a reference copy, right? That's a part you should really pay attention to. Okay, so now let's do number 6. We're almost there. Let's just complete it. For number 6, we are trying to do actually a bank objects, do a bank objects copy for caching. So now, would this be a very expensive or very cheap operation? Well, apparently you can see there's no twin and there's no deep twin. That means it's a reference copy that's involved in the caching, so that's always cheap. So what we can do now is to do this. We can say number 7 over here. What we will do is, so it's going to be current.twin, right? So now I would say old current and then twin. That one there is simply going to be assigned to the current. And the current, of course, is referring to this particular bank objects here. So that means now this particular cache variable is now pointing to here. Okay. Now, number 7 will take a little bit of time to draw. Number 7 over here is basically to also cache a bank objects, but it's going to be a shallow copy of the bank. So now how can we draw that, right? So now I want to draw it very carefully. So now let's do the following. Okay. How do we make a shallow copy of the bank? First of all, you got to create a bank objects. Okay, you make a bank object here, and then every attribute is going to be a reference copy. That's the definition for twin. So now, do we need to make any new objects anymore? The answer is no, we don't have to. So the accounts array is simply going to point to the same array that the original bank object is pointing to. That's the shallow copy. So now this is simply going to point to the same array over here. Okay, so this one is also so special, so I'm gonna highlight it for you. Okay, that's actually pointing to over here. Okay, and then let's do the caching. Okay, quickly. So now that I created the shallow copy. So now this is what I would like to actually cache. So now let's put it here. Number 7. Oh, actually, I beg your pardon. So this pink one is actually number 6. Okay, I just wrote it wrong. But hopefully from the color you can see I'm being consistent. So this is number 6, and the orange over here is number 5. Okay, and then the green one is actually number 4. Okay, so now I got all the numbers there. Okay, let's now say for number 7. For number 7 over here, okay, so now it's current.twin. So now let's say internally we simply name it as current twin. So that one is assigned to basically current.twin, right? So how is it going to look like? So that means number 7 here. So now current twin is assigned to current.twin, and the twin copy which have just created, which is over here. Okay, this is the red one. So now current twin is just going to point to this particular shallow copy. That's what it's going to point to. Okay, so now we have seen all these 7 objects over here. It gets a little bit not really messy, but I think it's systematic. It just gives a little bit too much information on a single page. But you can see what I'm trying to do here. I really want to compare all the range of all expression you can write in order to achieve your caching process. We're still trying to do some mental drills up to now. We haven't really seen a very complete example about using the O keyword and see how the caching process works to affect your post-condition evaluation. We will see that in the next part of the lecture. So now I want to conclude by saying, before you move on, please make sure you understand about how the caching, the mental model of your caching process, and then for this particular example, how each different O keyword expression is going to trigger a different value to be cached in the pre-state. Please review it before you see the complete example in the next topic. And before we move on to the next topic for a complete example about post-condition, I would like to show you one more, let's say, quiz question to actually test your understanding. So I'm going to show you the question here, and then I would suggest you pause the video just to take a few minutes to think about what the answer should be. Okay, let me go over the question with you. The code is actually not difficult, very straightforward. But let's just take a look, line by line. So we have a class called linear container, and then we got constructor here, and then we have an attributes A of type array of string, and then we have a query which is just return the size of the array, and then we also get a get query which will take some index I, assuming that I is simply just valid. We can assume that, and then it's returning a string, so it's just going to retrieve the elements at index I of array A. Okay, it's very easy query over here. And then we simply have the constructor over here, simply just initialize an empty array. Okay, so far so good. And the main method I would like you to look at is the updates method over here. The update method is very similar to what we discussed about how you can assign at a particular position of the array, whereas you want to make sure the rest of the array remains the same. Right? That's kind of the exercise we did together. So now for the update method over here, let's see. So the update method is going to take one intended index to be changed to this new value v. Okay, and then we just do whatever implementation that's conceivable to be correct. So now let's talk about the post condition. Especially we want to talk about others unchanged. So every slots except for the one we intend to change should remain the same. Okay, so now I want you to look at this particular cross expression. Across, and then we are using all over here, so that means it corresponds to the for all expression. So now we say across 1 to the size of the array or size of the linear container as j. And remember, when we talk about the across, when you say as over here as opposed to is, so now that means j over here is a cursor to integer, right? Just to remind you. Okay, if you have doubts, please refer back to your tutorial videos or notes. Cursor to integer rather than just integer directly. That is why whenever you want to refer to the integer itself, you had to say j.item and then j.item. Okay, just to remind you syntactically. So now in the logic over here, we simply say if and also j.item over here. So now it's overall is an implication that we are trying to write. We are saying the following. We are saying that if the current index value that we are looking at, so j.item is the current index value we're looking at, if it is not equal to the intended place to change, so that means that slot represents the place that shouldn't change. So that means the old version of the value that is stored at index j should be the same as the current version. So you can think about this is representing the value in the pre-states. Or think about this is the return value of the get in the pre-states, and this is the return value of the get at the same index in the post-states. And then since the slot that we are talking about, let me just make it a little bit more obvious to you if you don't mind. Let's say this is the array that we are talking about. This is A, right? Let's say we intend to change at index I to be V, right? To change from I to V. And now let's say when we are looking at, so what the in order if if we satisfy the antecedents, so that means we are looking at this particular region over here everywhere except for index I. Okay, so now we are saying that if we are currently looking at index j, and j is not equal to I, so that means j must remain the same from the pre-state to the post-states. That's basically what we are trying to say. Okay, hopefully you get an idea. Let me make it a little bit cleaner over here, especially for this part here. But I will leave the pre-state and post-states annotation over there for you. Okay, and then I'll leave just this whole thing clean for you. Okay, so now here's the question. The question goes like this. So what value exactly will be cached at the runtime? So when we actually try to check, let's say there's no precondition over here, so that means immediately before we try to execute the implementation for the updates feature over here, we have to cache all the old expression value for later execution, right? For later checks. So now what exactly will be the value that will be cached before executing the implementation of updates? Okay, so that's the question. What will be the value that's going to be updated? Okay, so I presume you have already thought about it. If you haven't, I would suggest you pause the video. Otherwise, now here's the answer. The answer is this particular fragment of code would not simply compile. Okay, so if you try to answer some value that's going to be, well, your answer might simply be this particular value is going to be cached. Well, I would say it's not a bad try. Actually I'm quite happy for you. It's actually at least you're trying to see the O keyword actually covers this part of the expression, and that's the shortest unbreakable units. And this tilde operator is actually can break, because you can definitely talk about left operand and the right operand, so it's breakable. Okay, so now the pink one I'm highlighting, if your answer was that this is going to be cached, I would say you're not wrong as a first step. However, if you think a little bit further, if you said to me that you're going to cache this particular value in the pre-state, let's say this particular value over here, so that means at this point over here in the pre-state, right? Let me just annotate it. So you're saying at this point over here, right before the implementation, you're trying to cache the following, right? Let me say cache. And let's say we simply just create some behind the scene variable automatically by the iframe compiler. So we say, let me just say get j item, right? Just whatever name it is. So now it should be cached by the value of this particular return value. Let me write it down, and then once I write it down, hopefully you might be able to see already what the issue is. So if I say get j.item, so now does this particular expression over here make sense in the pre-states? Give you some visual hints. J here in the pre-states and J here in the post-states. So this is why this across expression over here, where you use the O keyword, does not even compile. Okay, this is why. Okay, hopefully you're ready to see why it is the case. First of all, by looking at this particular O expression, which applies to the get j.item, so we know that in the pre-states we actually have to cache this particular, we create this particular caching variable behind the scene, and this is the expression we would like to evaluate and store in the pre-states. However, j.item is referring to j. J only exists in the across notation over here as dummy variable only in the post states. You can see this part over here is really the post states. So in the pre-states, you're referring to something that doesn't exist just yet. So J only exists in the post states. So if you try this in iFlow Studio, I encourage you to try. If you try this in iFlow Studio, you're going to see J does not exist as a variable. Okay? So that's a very common mistake when you actually try to use the O expression in the context of across, especially across all or across some for the quantification. Okay, review this example. I highly encourage you to actually put this very little fragment of code into your iFlow Studio and try it out. Okay, otherwise later on when you run into this particular error in your labs or projects, you wouldn't know how to fix it. Oh, actually, how do we fix it? That's a very important thing. So in order to fix it, I would say you will have to make sure the old expression should only be applicable, should only cover something that is that actually exists in the pre-states. Otherwise, it cannot be stored. So one possible fix is this. We should use parentheses to really break it earlier, right? What we can do, I'll just suggest one possibility for you. You can say old, okay, over here. You can say now the current object is actually a linear container. So what I can do is I can say current, okay, and now I want to make sure any change behind the first level is not actually wiped out from the pre-state. So I should really do deep twin in this case. Dot deep twin. Okay, and then I'll simply put a parenthesis. I'll explain why we need a parenthesis in just a moment, and then we can say dot get j.item. So this is going to fix it, because now if you think about it, so now what the old keyword covers is actually this particular expression over here. Apparently current does exist in the pre-state, so now we can definitely make a deep twin of that. And then once we make a deep twin of that, and then later on when we evaluate this particular expression, we're going to use a cache version in the pre-state and then say get j.item. So that would make sense. Okay, think about why this fix will work. And then I want to suggest another possibility to you which may not work. What if I say old current dot deep twin dot get j.item. The difference really is, let me highlight, in the fixed version, in the correct fixed version, I have the parenthesis, but now in this particular wrong fixed version, I don't have the parenthesis. Okay, so now again, if you're not think about it, pause the video before I tell you the solution. Okay, so now here's the solution. What does the old keyword cover? It covers current dot deep twin dot, so we got to continue dot get j.item. So that means you're going to evaluate this particular expression in the pre-states for the caching. So now evaluating this particular expression is no better than evaluating this particular expression. I would say these are really the same, because you still have to evaluate j.item like j.item over here in the pre-state. So it doesn't really help in fixing it. Okay, so actually I covered quite many details over here. So please review this particular example. I think it would be very helpful if you try to understand and link it together with what you learned from the previous examples, like over here. Okay, link them to what you learned in all the various cases and see why this very first version and also this wrong fixed version is actually will still not compile in Apple Studio, but only this fixed version will compile. Okay, think about it.